So let's talk about some of the different forms of models. I'll start from the more simple ones and go towards the more complicated ones. Now perhaps the simplest form of model is to model by analogy. So you're saying the situation we're facing now is, that's a bit like 5 years ago. And that's a model. It's saying the situation is analogous to the one 5 years ago, and therefore what happened 5 years ago is probably a good prediction for what's going to happen now. Now this, for example, is how all weather forecasts were done until computer models came along in the 1960s. So what people would do is they'd get all the data from their weather stations on land and on sea and use that to come up with a weather map of the pressure systems, and then say, okay, now that's actually quite similar to what we saw 5 years ago back on 13th of September, using their memory. A weather forecaster will be someone who spent ages and ages looking at these charts, and therefore they'd have good memory of other situations, and they'd say, this looks like similar to that, what happened back then, and therefore predict what was going to happen. This chart is actually the one for the D-Day landings in World War II, when the Allies landed in France to expel Germany. And the Allied weather forecasts were more accurate than the German ones. So the German ones thought that the weather was going to be too bad no one could land, and so they relaxed all their troops, whereas the Allied ones realised there was going to be a short window of good weather, and therefore the landings went ahead, as you can see here. This is a very common form of often implicit modelling. You listen to politicians, they always say, we've got to do this because it reminds us of the Great Depression, or it reminds us of appeasement, or something like that. But it's also a bit dangerous because often there are multiple analogies. For example, you often hear politicians saying we've got to be like Winston Churchill and stand up to whatever enemy country we've got, which is an analogy with World War II. But you could also pick an analogy with World War I, and then you come to a quite different conclusion. So you've got to be careful that your analogy is appropriate, that you are actually picking a comparable situation, and often you have a choice of different situations. Like in a weather forecast you might say, well, it looks like the 13th of September 2005, but also like the 7th of November 1997. Which one's going to be the case? So it often go wrong. In the early days of the COVID pandemic, a lot of people were thinking that this was going to be similar to other pandemics they'd seen, and it turned out not to be, and so often their analogy was not very good because the disease was different. But it's a very common technique. A slight variant on this is extrapolation, where you look at data in the past and just assume that whatever the trend is you see there is going to keep going. This, for example, is what Elon Musk said when in the early 2000s he decided to invest in electric cars. He could look at the trend here in the price of lithium-ion batteries and see that over the previous 10 years they'd dropped by about a factor of 5 in price. And so if you extrapolate that, then by the year 2010 you could start selling luxury cars using lithium-ion batteries, and by 2020 you could start selling non-luxury cars. And in his case, the extrapolation worked. Of course, this is very dangerous. You're assuming that the past trend will continue, and unless you know what's causing the past trend, that might not be a good idea. But nonetheless, it's a very, very common method of modelling. So you're saying basically whatever trend happened in the past will continue to go, and sometimes it does and sometimes it doesn't. So this can be useful, and sometimes it can be very dangerous. I remember we were trying to set up a photonics teaching program here at ANU, and they looked at the trend of the number of people studying photonics. It was going up, up, up. So we thought there's going to be millions of people. This is going to be a great money spinner. We're going to teach everyone how to do photonics. But in fact what happened was it went up and then stopped. Well. Then you can actually have simple mathematical models. This is like a projectile motion for a physicist, but there are these models in all sorts of situations. Economics is particularly famous for it. Here, for example, is a supply and demand curve. So any economic students will be very familiar with these, but for those who are not economic students, the basic idea is, let's say you're trying to look at the market for something, let's say renewable energy. And there's a supply curve which is telling you how much renewable energy will be supplied depending on what price you can earn. So let's say you can sell electricity for $1 million a kilowatt hour. In that case, everyone's going to be building wind turbines and solar plants because you can make so much money from them. The cost-benefit equation is very positive. Whereas if you're only going to make 1 cent per kilowatt hour, no one's going to be building anything because they can't make their money back. So you're going to have an upward sloping graph. The more money you can make from something, the more of it you're going to make. More people will flood into the industry, and it'll be more economic to build big turbines in different places. Whereas if it's very cheap, you're not going to make very much of it. You have to have a really good business case to succeed. There's also the demand curve. So how much electricity are you going to use? Well, if electricity costs a fortune, you're going to use something else, gas or horsepower or something like that. Whereas if electricity is really cheap, you'll leave the lights on at night and have electrify everything. So the amount that's buys goes down as the price goes up, the amount that's supplied goes up as the price goes up. And so there's usually a point where the two meet, which is what orthodox economics tells you you will sell these things for. This is where supply meets demand, and that'll be the price and the quantity consumed. And these models can be useful. For example, let's say a new technology comes along and makes it cheaper to produce electricity, like new solar cells. What that means is you need less price to produce the same amount of electricity. So the supply curve moves to the left, demand curve doesn't happen. What will happen is you're now coming at equilibrium here rather than there, which means more electricity will be consumed at a lower price. So that's a good prediction from a model.